All right, sometimes when you're doing probability, you know, that denominator, that bottom number is your total. And sometimes, like when you're doing a deck of cards, you know, the total's 52, or when you're trying to roll a die, you know, there's 6 different things on the die. So a lot of times you know the total, but a lot of times you won't know the total when the problem starts. So what we're going to talk about in this video is how do you find a total when you don't know it? All right, so as usual, I'm going to share the screen and pull up a PowerPoint and kind of talk you through it. I hope that helps. All right, so finding a total. All right, so let's look at 3 different ways. Now, you're going to need to get some paper out or print this or however you want to do it, but you're going to need this in your notes. Okay, so we're going to kind of write down an outline, and we're going to kind of talk our way back through the outline when we're working the problems. But if you have this copied on a piece of paper or printed out for your notes, so kind of get this on your paper, then stop the video. All right, so get that down, stop the video, and have it beside you before you go to the next slide. Otherwise, I might lose you. Okay, so there are going to be 3 ways to find a total. All right, the first way is going to be called the fundamental counting principle. And the second way is going to be called permutations. And the third way is going to be called combinations. So I know right now you have no idea what I'm talking about, but you're kind of a scribe. You're just writing it down, then we'll kind of talk our way through it. But this outline being beside you when I kind of go through each one individually will be helpful. Because in a minute, I'm going to have you notice something. One of the first things you're going to want to know is, does order matter? And the answer is either yes or no. So if order matters, you're going to have a couple of choices. All right, so notice that the fundamental counting principle, whatever that is, order matters on that one. So if order matters, you might use the fundamental counting principle. Notice also that order matters on permutations. But if order does not matter, then for what our purposes are, you're going to be using combinations. So that'll kind of help you take your 3 and divide it into either these 2 or this 1. All right, notice the difference between these 2. With permutations, it's really nice and sweet and quick, and order matters, but no replacements allowed. So once you use the number 4, you can't use that same number 4 again. Okay, once you use the letter Z, Z's out. But on the fundamental counting principle, it's more flexible. You can use it with replacement or without replacement. So whether you put the Z back or not, we can fix that with fundamental counting principle. And then other flexibility that the fundamental counting principle brings to the table is you can kind of use it with special conditions, like the numbers got to be even, or you can't repeat the A or something like that. So let's kind of talk our way through each one, but make sure this is beside you before you go to this next slide. Okay, assuming you followed my instructions and you've got it beside you. So the first way, we're going to talk about something called the fundamental counting principle. All right, so the fundamental accounting principle basically, it's just a way of finding totals. Like for instance, here's one of the ones that says, if you've got different events that are kind of separate events, and the first event can occur in ways, like n might be 4, and the second event can occur m ways, like 8, then the total ways you could do both in that order would be 4 times 8, 32 times. So basically, the easiest way to do fundamental counting principle is, first of all, order matters. Okay, so remember back to that slide that you're looking at, hopefully that you've got it beside you. So order matters. All right, so I'm going to use this fundamental counting principle, because think about it, if you drive up to the ATM machine and you go to punch in your PIN code, does the order you punch those numbers matter? Yeah, it does. So what if I ask you how many PIN codes are possible for your checking account? Like when the computer assigned you that 4-digit number, how many choices did the computer have? Well, order matters. And like in my PIN code, one of my numbers is repeated. All right, so that's the reason that I would not be able to use this thing called permutations, because with permutations, you can't repeat something. So no replacement, no repetition is allowed. Okay, so think about how I would do that. Now think about all the single digits when you type in your PIN code. One of your numbers might be a 0 or a 1, a 2, a 3, a 4, a 5, a 6, a 7, a 8, or a 9. So do you understand that when the computer went to assign you this first number right here, all right, then it basically had 10 choices. It could have used a 0 or a 1 or a 2 all the way to 9. Now, when the computer went to assign the second number, could it repeat? Could you have like a 2 in your PIN code? You could. So that means there's still going to be 10 choices for this one. And because it can repeat the number, there are going to be 10 choices for all of these. All right. So what that means is, that means that when you do 10 times 10 times 10 times 10 on your calculator, you're going to get 10,000. So there were 10,000 different PIN codes it could have assigned you. So see, what if the problem said, somebody steals your ATM card? So what's the probability that they're going to get your PIN code the first time they type it in? So they drive up to the ATM and they've got your PIN code and they stick it in. Remember what we talked about? I want you to put in parentheses the event you're looking for. Now remember what I told you before, what's in the parentheses goes on top. So for that checking account, how many PIN codes do you have? Well, see, you just have one PIN code. My Regions account just has one PIN code associated with it. But what I wouldn't know without doing all this would be how many PIN codes were possible. So I have to go over here and figure out that there are actually 10,000 different PIN codes. It's hard to write with this little stylus. That's not an 8, that's a 0. That's a 0. Okay. So let's make that look a little bit better. So the chance of that thief driving up and typing in my PIN code is 1 out of 10,000. That's the reason that a lot of times when you drive to an ATM machine, most ATMs give you 3 chances. In case somebody has stolen your card and just punching in some guesses. Most of the time after you do it the 3rd time, either it locks your account or kind of eats your card. And by eat, I mean it won't give it back to you till you go in the bank. Okay. So, you know, that's the reason, because if you had a really, you know, persistent thief, they could just keep punching in. If they were smart and organized, they could keep punching in, and 10,000 times they should have the right code. So it doesn't let them do that. Now, the problems get sometimes a little more challenging, which I think is a little more fun. Okay, so look at this one. How many, like what if it was a secret code? All right, so how many secret codes are possible with these conditions? You have to use 3 single-digit numbers. So again, like 0 to 9, followed by 2 letters of the alphabet. Okay, so you got 3 numbers and 2 letters. But here's some special conditions. The first 2 numbers have to be odd. The first letter can't be Z, and no repetitions allowed anywhere in the problem. Now, think about it. If you've got a special code, wouldn't order matter? Yeah, it would. All right. So notice, if order matters, all right, let me kind of go back up here. All right, and let me kind of erase these drawings. All right, if order matters, notice you cannot use combinations. Okay, so that would narrow it down to either the counting principle or permutations. Remember, this problem had special conditions, so that knocks out permutations, and you have to use the fundamental counting principle. Okay. All right, so that's how I knew which one to pick, so to speak. So I know when it's fundamental counting principle, I start drawing blanks. So I drew 3 blanks here and 2 blanks here. Now, for me, I write myself notes under the blanks if there's some special conditions. That just helps me. All right, like it told me that these were all numbers. So I have number. And then it said the first 2 have to be odd. So I put odd number. Oh, excuse me, it should be odd, not even. Odd. And then this one needs to be odd, not even. Okay. So I've got an odd number and an odd number. And then this one didn't have to be odd. Just the first 2 numbers had to be odd, but it did have to be a number. So I put a number under it. All right. It did tell me that the first letter couldn't be Z, so I put not Z. And then this had to be a letter. So I just wrote myself some notes under them so I wouldn't get confused. All right. The first number has to be odd. All right. Now think about all the odd numbers. 1, 3, 5, 7, 9. So there are 5 different odd numbers. So I'm not picking the number 5. I'm saying there are 5 different odd numbers from which to pick. So that's why there's a 5 in that blank. Now, when I got to this blank, why is there a 4 there? Remember what it said, it's got to be an odd number. So again, I go back to the odd numbers, 1, 3, 5, 7, 9. They're 5. But remember, I've already used 1 and I can't repeat. I can't replace that and use it again. So that left me 4 choices here. Okay. Now, it didn't say anything about this except it had to be a number. So think about all my numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 numbers. So why is there an 8 in that blank instead of a 10? Because I've already picked 2 of the numbers and I can't repeat. I can't replace those and use them again. So that's why there's an 8 in that blank. Now think about all the letters of the alphabet. A through Z, if you count them up, that's 26. So if I can't use Z, I throw Z out, that left me 25. So that's why there's a 25 there. Now, why is there a 25 here instead of a 24? Because there's not any special conditions. So how many letters are there? There are 26 letters, but I've used 1 up. So that leaves me 25 because see, Z gets thrown back in. So I can't use Z here, but I can use Z there. And then I just multiplied 5 times 4 times 8 times 25 times 25 on my calculator and got 100,000. Okay. So if you do counting principle, just draw blanks and each blank do it separately. But notice whether you can repeat something like up here, you could repeat, and down here you could not repeat. So if it had been even numbers, 0 is even. So do remember 0 is even, don't forget it. Okay. So hopefully that'll help you with the counting principle. All right. So let's go back now and look at permutations. Now the formula for permutations in your book looks really weird. It looks like this. N is the total from which you're picking and R is how many you're picking. All right. So instead of number you're picking, let's kind of change that to how many you are picking. All right. So now 5, and this actually looks like an exclamation point. In math, that's called a factorial. All right. Factorial. It's called a factorial. It's not an excited 5. All right. It's a shorthand notation for saying that number times every whole number under it to 1. So like 5 factorial means 5 times 4 times 3 times 2 times 1. In other words, it's a short way of saying 120. All right. So do you understand if it said 3 factorial, that would mean 3 times 2 times 1, which would equal 6. And then by definition, 0 factorial is 1. So if you ever see a 0 factorial, that's just a 1. They had to define it to be something. So instead of it being 0, it's a 1, which is a little strange. All right, so go back to this and remember, with permutation, order matters and there's no repetition. So if it's no replacement, if that bothers you, you can always go back and say no repetition, if that communicates better to you. So you're taking the notes, so you do it whichever way works better for you. Okay. So I double check. Look at this problem. There are 10 cities that you're going to visit. Like you're going to get in your car and drive to 10 different places. All right. Excuse me. You're going to drive to 4 places. There are 10 cities that you want to visit, but this time you've only got time to visit 4. How many routes are possible? Okay. Now route means the path your car took. So on your test, okay, when you have your test with this on there, if you're confused about whether order matters, you can come up to me and ask me, does order matter? And I'm going to nod yes, or I'm going to nod no. Here I would nod yes. I mean, think about it. If I wanted to visit Memphis, Tennessee, Birmingham, Alabama, Jackson, Mississippi, and Biloxi, Mississippi, It would be different if I drove from Biloxi to Jackson to Memphis over to Birmingham. What if instead I went from Biloxi all the way to Memphis, then went over to Birmingham, and then went back to Jackson? Would I be on the same roads? Would my mileage be the same? Would my route be the same? No. So if you change the order, you change the route. So order matters. So I cannot use this thing called permutations. I mean, this thing called combinations. So combinations is out. So I can either use the counting principle or permutations. Now on this one, I could use permutations or the counting principle, and I'll show you why in a second. But since for this example, since I'm not repeating the same city, I'm not going to Biloxi twice on my trip, then I can use permutations. So do you understand why there's a 10 here for N? Because N is how many there are to pick from. There are 10 different cities. R is how many you're picking. I'm picking 4. So all I did was replace the N with 10 and the R with a 4. Okay, so that's 10 factorial. Remember your order of operation, you got to do parentheses first. So 10 minus 4 means 6 factorial. Now, what does 10 factorial mean? Well, 10 factorial means 10 times 9 times 8 times 7 times 6 times 5, all the way down to 1. Well, what does 6 factorial mean? Well, 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. Now, if you try 10 factorial, sometimes we'll talk about in a minute with your calculator, it may be too big for your calculator to take. But think about it. Do you see that the 6 is up here and the 6 down here are going to divide out? What you think of as cancel out. So all of these would divide out with all of those. So it's really just going to leave me 10 times 9 times 8 times 7, which is 5,040. Okay. So a lot of times, instead of writing it this way, here's what will happen. Sometimes they will just write like 10 factorial, 10 times 9 times 8 times 7 times 6 factorial on the top. All right. And then down here on the bottom, they'll just write a 6 factorial. And I'm not going to take time to draw the division bar, and they'll just cancel out this 6 factorial or that 6 factorial. Okay, so permutations, the N is how many you're picking. All right, and the N is the total from which you're picking, and then the change this back to where it was. All right, the N is how many you're picking from, and the R is how many you're picking. All right, and order matters. All right, now look at combinations. Combinations, the formula looks almost the same. So you still got an N factorial and you got an N minus R factorial, but you got this extra R factorial on the bottom. All right, so N is still the total and R is still the number that you're picking. All right, so here's an example. There are 20 people in your club and you're going to pick 4 of them to serve on a committee. How many committees are possible? Now think about it. If you had a committee with Dick, Sally, Jane, and Steve, that'd be the same committee if you had Steve, Dick, Sally, and Jane. So the order that the names are written in doesn't change the committee. All right, so order does not matter. And if order does not matter, you have to use this thing called combinations. All right, so I went to see how many were there total. There were 20 people total. So my N is 20. All right. And then how many am I picking? It says you're going to pick 4 of those 20 to be on your committee. So my R ended up being 4. So all I did was go back and replace these N's with 20s and those R's with 4s. All right. So again, 20 minus 4 is 16. So this is what I meant before. So rather than doing 16 times 15 times 14 all the way to times 1, I just said 16 factorial. I stopped at 16 factorial because there was going to be a 16 factorial on the bottom. Then I could just cancel out one number each rather than a whole group. It's just a little bit less writing that way. So look what that leaves you. It leaves you 20 down to 17 on the top and 4 down to 1 on the bottom, which ends up giving you 4,845. All right, so let's go back and real quick. The first thing you're going to ask yourself then is, does order matter? All right. And if order does not matter, then you have to use combinations. All right. So if order does not matter, you must use combinations on your homework problems. There are other things out there, but we're not going over those. Okay. You're not responsible for other things, just what I'm doing on the video. Now, what if order does matter? Well, if order does matter, then you've narrowed it down to either the fundamental accounting principle or permutations. Now, if you're in doubt between those, do the counting principle. The counting principle works all the time, even when permutations works. Okay, so if you're in doubt, do it this way with the fundamental accounting principle. Okay, if you're sure that there are not any special conditions and you're sure that there's no repetition, then you can use permutations. Now, here's the lovely thing about number 2 and number 3. Your calculator does it for you. These formulas right here, this formula right here, and this formula right here are programmed in your calculator. So what I want you to do is I want you to copy these steps down on in your notes. I'm going to talk you through them. So get your calculator out. All right, so freeze it and go get your calculator if you need to. All right, you should already have it, but just in case. Then we're going to go back and rework those other problems using the calculator. All right, on your calculator, on the first column, remember columns go up and down. On the 4th button down, it should say math. So I want you to hit that math key. Now, when you do, across the top, it says math, NUM, CPX, and PRB. I want you to take those arrows and scroll over to the right until you see PRB. When you do, a menu comes up below you. And I want you to notice number 2 and number 3. They should look real familiar. Number 2 is NPR. That's your probability with permutations. And NCR is probability with combinations. But the order that you do, it's going to matter. So when you go to work a problem, you don't go here first. The first thing you're going to do is you're going to type in your N. Then you're going to go to the math key, scroll over to probability, decide whether you need permutations or combinations, choose that one, do your R and hit enter. Now, what do I mean by all that? All right, make sure this is copied down. So freeze it and copy this. All right, now that you've got this copied, we're going to go back and work these other problems. All right, do you see this problem right here? There are 10 cities that you want to visit, and you're going to drive to 4 of them. How many routes are possible? So instead of doing all this, here's what I could do. I'm going to take my calculator. I've cleared my screen, so I've got a blank screen. My cursor's just blinking. First, I'm going to type in my N. So you do need to always write this part right here down. Even when you're using the calculator, this is your partial credit. Put your N, tell me that you're doing P, and put your R. All right, always do that. So you're going to type in 10 on your calculator. Then you're going to hit the math key. You're going to scroll to the right until you see probability. Now, are you doing P or C? That's why I want you to have it written down. You're doing P. So come down to number 2, and hit enter. And the cursor should be blinking at you. It's waiting for you to type in the R, and our R is 4. So hit 4 and then hit enter, and it should say 5,040. All right. So that's way easier than you do it yourself. So aren't you glad you bought the calculator? All right, let's go work this one with the calculator. All right, the same thing. You've got to type in, so clear your screen again, just to make sure we're just looking at one thing. So blank screen, cursor's blinking. Type in your N. That's why I want you to always write this. So you were doing combinations because order didn't matter. 20 was your N and 4 was your R. So you type in 20. So on your screen, you've got a 20. The cursor's blinking at you. You go to your math key and hit it. Then scroll over to probability. Arrow down until you see NCR. So when your cursor is on NCR, hit enter. And it's waiting for you to type in your R, and your R is 4. And then hit enter, and it should say 5,845. So the calculator will do all the work for you. Okay. Now let me kind of go back and show you one more thing, and then we'll be done. Remember I told you if you're in doubt, you can use the counting principle. All right, so look at this one. Order mattered. So instead of doing permutations, I could have drawn my 4 blanks. Okay, with times between them, remember. All right. So if I'm picking cities and I go to pick the first city, how many cities are there to choose? Aren't there 10 cities? So see, this would have been a 10 with the counting principle. Now, once I pick a city, I'm not going to visit again, so it's gone. So now how many cities do I have from which to choose? Now I got 9 left. So I picked my second city. So now I had 10 cities, but I've already picked 2. Now I've got 8 left. And when I get here, I've only got 7 left. And when you do 10 times 9 times 8 times 7, you get 5,040. So that's what I mean. If order matters and you're confused, use the counting principle because it works even when permutations works. The only advantage to permutations is it's a button on your calculator. All right. So hopefully that helps. If you need some help, you've got my email address. All right. So hope it goes well.